All right, welcome back to Everything Mathematics. And today, Friday, we're going to wrap up with this concept, solving simultaneous equation using matrices. And this could be a long process. So as a result, I will only do one question, but I'll trust to explain the concept good enough so that even though I only do one example, you will be able to take any other question and of course apply the same concept because it's the understanding the concept is what matters and not necessarily doing the example, right? Or at least that's what I believe. I'll explain the concept first, and then we're gonna solve it, or I'll show you how to go about solving it. So in essence, generally, we get a simultaneous equation is basically a system of equations. So we have two equations most times. You could have a linear, you could have a quadratic, you could have two quadratics, you could have two linear. In this example, I will use two linear equations. In fact, I'm not even sure if you have a quadratic if this will work. I'm not sure. In fact, I don't think so. But say what? We're going to be using two linear equations, and I'll just write them down. So the equations that we're going to use in is 3x plus 4y. And as usual, I'm telling you in advance, I did not try this out, so I don't even know what I'm supposed to get. 2x plus 2y is equal to 12. In fact, for what it was, when it comes to solving simultaneous equations, there are three different ways in which you could solve them. Most commonly, of course, we use the elimination substitution method, but outside of that, you should be aware that you also exist the graphical method where you have to draw a graph of the two equations, and of course, wherever they intersect, those are your points, your common points. And of course, you have matrices. So you have graphing, you have matrices, and you have the substitution elimination method, which is the number one way that you're taught, and the others come along the way. So I'll explain the concept. When you get these two equations, you're supposed to make matrices out of this equation. And your matrices will look something like this. So you have A, which will represent the coefficients of X and Y. The coefficients are the numbers that are in front of the X and Y. That will make a matrix. Then you have X, and this is just a generalization. The X will be the unknown. So that's your X and your Y, the two things that you're trying to find. And then you have another matrix, let's call that matrix B. And in matrix B now, you have basically what is on the other side of the equal sign. The whole idea is this. We want to find what is X and Y. And X and Y is represented by this X here. So in essence, it's like we're making X the subject of the formula. How do we do that? We get rid of the A. So we divide by A. And if we divide by A, on the other side, we also divide by A. Note, A is a matrix. So this cancels this, leaving us with X is equal to B over A. But there is no, well, let me not say there's no such thing. We don't really divide matrices, or at least as far as I'm concerned, it's not anything we were ever taught in high school, though possible. So instead of A over B, we apply our indices rule, which simply says whatever we have a denominator, we throw it at the top as an inverse, and we multiply that by B. And this here is really and truly your golden rule when it comes to solving simultaneous equation using matrices. So in other words, for us to get X, or for us to find the values of X and Y, we basically have to multiply the inverse of the coefficient by the result on the other side. And that's just the concept. Let's see if we could apply it. That's just the concept. And another concept comes to play here, but I would not go there. I would not go there. I'll leave it like that. So let's make our matrices A, X, and B. Let's do that. So remember, the matrix A are the coefficients of X and Y. The coefficient is whatever is in front of X and Y. So here we have 3, we have 2, the position is very important, 4, and 2. Moreover, I will emphasize, and this is where sometimes it could get technical, if your equations are not given in the format in which I have it here right now, ensure that you manipulate your equation so that it looks exactly like this. X's under X's, Y's under Y's, constant under constant. That is very important. Sometimes you might get an equation, for example, this same equation here, sometimes you may have gotten it like this. 4y plus 3x equal to 20. And mind you, I'm telling you, this is the same thing, right? this equation here and this equation here are the same thing, but they're just not positioned the same way. So you want to make sure that you position it, the x's first, then your y's, then your constant. So this is the matrices A. So we could call this matrix A, which is the matrix made of coefficients. Then we have our unknown values. So x and y, that makes a matrix. And then we have the matrix of the constant, which is 20 and 12. So we could see it as B. So if we go to make a comparison here, technically what we have is A, X, B. The same thing like over here, right? Just for comparison's sake. Good. What we do here now, we divide by this whole matrix, but let's just make a long story short. In essence, we need the inverse of this matrix here, and we have to multiply that by the other side. That's what we do. And some people might wonder, well, if I multiply the inverse on the other side, why don't I multiply the inverse on this side? But remember what we did 2 days ago. When you multiply the inverse of a matrix by the matrix itself, you will end up with the identity. And the identity is the same thing as 1. And anything you multiply by that, you will get the same thing. So in essence, there is no need, really and truly, to do that. Well, I mean, if you're idle and you have time to waste, you could multiply it on both sides, but you realize that on one side, you'll get the identity. It's just like multiplying by 1. You know you'll get back the same thing. So it's like, why go and prove that? Good. So yes, we need a little work here to do now. So now we have to find the inverse of this matrix so that we can multiply by this other side. So let's start with the determinant. The determinant, and let's call that matrix A. Let's call this matrix A. So the determinant of A again is leading diagonal. So that's 3 times 2 minus minor diagonal, which is 4 times 2. Good. And that will be the same as 6 minus 8, which is equal to -2. Determinant, check. Adjoint. The adjoint of matrix A is equal to, remember, we switch positions of the leading. So where the 3 is, we put 2. Where the 2 was, we put 3. And on the minor, we change signs. So 2 becomes -2, and 4 becomes -4, or -4. So there we have our inverse. So let me just write it out. A inverse right now would be 1 over the determinant, which is -2, and we're multiplying that by the adjoint, which is 2 minus 2 minus 4 and 3. And because I need to multiply this by another matrix, I will distribute my scalar. So a half multiplied by 2, that would be -1. A half multiplied by -4, that should just give us +2. A half multiplied by -2, that will give us +1. And 1/2 multiplied by 3, that should give us -3/2. A little more we would have had only whole numbers, but that's not the case, unfortunately. Right, so let me just go back to the top now, 2012. So what we have here now is this. We have x and y on this side is equal to the inverse, which we just got there, the inverse, which is A inverse, -1, 1, 2, and -3/2, and we're multiplying that by B, remember. So that in this case is 2012. And once we solve that now, the value at the top will be our x value, and the value that will end up at the bottom is our y value. Just for what it was, and we did this last week, remember, whenever we multiply two matrices, we have to test the conditions to see if it is what? Eligible for multiplication. This matrix here is a 2 by 2. 2 rows, 2 columns. This other matrix over here is a 2 by 1. 2 rows, 1 column. So number of columns is equal to number of rows. So yes, it is eligible. And guess what? Your resultant matrix will be a 2 by 1, which is a matrix that looks like this. Good? So once that's out of the way, we have x and y is equal, and I just multiplying these two matrices here. Let me see if I could do this right here. At the top, we will have -1 times 20. So -1 times 20 plus 2 times 12 plus 2 times 12. Oh, well, that one will work out easy. And at the bottom, we have row by column, remember. So 1 times 20, but positive now, 1 times 20 plus 3/3 times 12. negative 3, that's a 3/3. Negative 3/2, getting a notification here. Negative 3/2 times 12. Good. And once I do that now, I have my solutions for x and y. As I said, it could be a tedious process, but once you understand what is happening, it's not very difficult at all. So 1 times minus 20, that will be minus 20, plus 2 times 12, that will be 24. So the top worked out pretty nice. At the bottom now, we have 1 times 20, which is 20. Oh, this is supposed to be a plus, not a minus. Ah, well, it will end up being a minus because of this over here. Minus, if I multiply this two fraction here, 3/12 are 36. So here I'm supposed to have 36 over 2. Yes, 36 over 2. Oh, and we will end up with a fraction. Let me just do this fraction here below across here. So that's 20, let's say, over 1 minus 36 over 2. And the easiest way to do this is just multiply here by 2, both top and bottom. And once I do that, I will end up with, guess what? Just double the fraction. So I have 40 over 2. So at the ending of the day, 40 over 2, that will be 40 minus 36, which will give us 4. And the denominators remain the same, which is 2. Wow, this works out very nice. So at the ending of the day, guess what? X and Y will be equal to, at the top, oh no, this is supposed to be our operation sign. This is a plus, not a minus, not multiplication. So minus 20 plus 24, that's supposed to give us negative, no, positive 4. And at the bottom, we saw that we get 4 divided by 2, so that's 2. Oh my, this worked out sweet. I never see these two simple numbers coming out of all this working. So in essence, what we're saying here is that x is equal to 4 and y is equal to 2. Sweet. One of the things you could do to prove that, and we generally do that sometimes, you could plug these two values into the equation, any equation, because usually we label them. So we say this is equation 1, let's say this is equation 2. And if we plug any of those two values into this equation, whatever we get supposed to prove this. So if I put x here and I put y here, when I solve this side, I'm supposed to get 12. So let's quickly do that. We just found x to be 4 and we found y to be 2. So instead of x here, let's put 4. Good. And instead of y, let's put 2. And does this solve for 12? 2 times 4 is 8, and 2 times 2 is 4. Oh, well, I don't want no other proof. 4 plus 8 is 12. So yes, that is how we go about solving simultaneous equations using matrices. I know, as I said, it's a tedious process. If you don't understand it again, feel free to leave a comment. I will gladly do another example, or you could give me a question of your choice and I will go through it slowly with you online again. And of course, as anything else, guys, with practice, you get better. So go through these steps easy, go through these steps slowly, pause where you think you need to pause, and do another example and see if you could get the answer. One of the things I do sometimes, of course, I solve as a matrix, but if I really want to confirm that what I did was correct, then I go back and do it by elimination and substitution. And if I get the same thing because you're supposed to, then of course, more than likely, what you did was correct. So again, that will be the ending of today's video. As always, feel free to subscribe if you haven't as yet. Enjoy your weekend. And next week, we're going to continue on Monday with everything mathematics. Until then, you take care.